This is the AI blog generator. It's a Spring Boot API that takes a topic, turns it into a blog post using OpenAI, and publishes it to a GitHub repository, all in one request. I'll walk through the full chain of calls when you generate a post with 2 iterations. At a high level, 4 API calls happen in sequence. First, OpenAI generates an initial draft of the blog post. Second, OpenAI reviews that draft and produces editorial feedback. Third, OpenAI rewrites the post incorporating that feedback. And fourth, the GitHub Contents API commits the finished post as a file in the repository. Let me go through each of these in detail. You send a post request to /API/generate with a JSON body containing a topic and iteration set to 2. That tells the system to generate a draft, then run one round of review and revision before publishing. The request hits the Generate controller, a Spring REST controller. It extracts the topic and iterations and hands them to the blog generator service. This service is the orchestrator. It doesn't call any external APIs itself. It coordinates 2 other services, the LLM service and the GitHub service. The blog generator service calls the LLM service's generate post method. Inside, the service sends a request to the OpenAI Chat Completions API. The request includes a system prompt telling the model to act as a technical blog writer and return raw JSON with 4 fields: title, description, tags, and content. The user message is "write a blog post about," followed by the topic. The model is GPT 5.2, temperature 0.7. That's API call 1. OpenAI responds with a chat completion. The service parses the response, extracts the message content, and passes it as JSON. It pulls out the title, description, tags, and markdown content, generates a URL-safe slug from the title, and sets today's date. All of this becomes a blog post record. Because iterations is 2, the draft doesn't go straight to GitHub. It enters the review-revise loop. The LLM service's review post method sends the draft back to OpenAI with a different system prompt. This time, the model acts as a senior technical editor, returning bullet point feedback on structure, depth, clarity, and engagement. That's API call 2. Next, the revise post method sends a 3rd request to OpenAI. The user message contains the current post and the editor's feedback. The system prompt tells the model to revise the post, addressing that feedback, and return the result as JSON in the same structure as before. The service passes the revised JSON into a new blog post, keeping the original slug and date. That's API call 3. The blog generator service now passes the final post to the GitHub service, which formats it as an MDX file. MDX is Markdown with a YAML front matter header containing the title, date, description, and tags. The service base 64 encodes the entire file, then sends a PUT request to the GitHub Contents API. The request body includes a commit message and the encoded content, authenticated with a personal access token. That's API call 4. GitHub creates the file and responds with the commit details. The service extracts the commit URL from the response. That URL travels back up the call chain. The blog generator service wraps it into a response with the slug, title, and a status message, and the controller returns it as the HTTP response. So the full chain for 2 iterations is 4 API calls in sequence. Call 1, OpenAI generates the draft. Call 2, OpenAI reviews it and produces feedback. Call 3, OpenAI revises it using that feedback. Call 4, GitHub commits the final MDX file. If an external API call fails, a global exception handler returns a 502 bad gateway. If something goes wrong internally, like a passing failure, it returns a 500. The end result is a reviewed and revised blog post committed to the repository. From there, Vercel picks up the new commit and automatically rolls out a redeployment to production, so the post goes live on the site without any manual steps.